All right, so right, we just looked at domain methods, right? Those are the methods that are specific to your domain, right? In this case, it was duration, and being able to convert seconds, right? Add to durations and whatnot. Let's look at some of the other standard methods, the methods that are more generic, like for instance, being able to compare two durations, equals, yes, or toString, right? Or any other method that we might be inheriting because we're extending comparable, right? Also, usually when you override the implementation of equals, typically you also need to override the implementation of hashCode, right? That we want to make sure that if these values are going to be used for comparing them against each other, or being able to put them in a hash table, or we want to have a unique identifier that we can uniquely identify this object, right? Either by adding hours, minutes, and seconds and hashing them together somehow, so that they can be used in a hash map. Right. So since we are extending comparable, right? We need to be able to compare them, right? And there's certain functions that we need to implement to let Java know, how do I compare two durations, right? Do I compare? One way would be to convert them back into seconds, and if 1 second is bigger than the other, according to the second law of thermodynamics, time flows in one direction. So we can say that one is bigger than the other, or we can say hours, minutes, and seconds, and see that right, if you have hours, one is bigger than the other, and minutes and the seconds are bigger, then we can determine we can compare them, right? So the comparable interface, right, exposes this particular function, the compareTo, right? And so it gives us a chance to let the comparable interface to know whether one is bigger than the other. So that's easy. We know we can compare longs, right, long values. We can convert them both into seconds, right? This current instance, convert it into seconds, convert the other instance also to seconds, and then just use the native implementation of compare that can compare just two longs, right? Once we do that, right, it's very easy to go and implement the compareTo. Again, it's an override. We want to make sure that we're writing the signature correctly, right? And the compiler will let us know, right, if we tag it with an override. Right, and compare is just a static. It's a static function off of the class, the class long, right? That knows how to compare little longs, lowercase longs. Also, toString is also a very convenient function that we should always override, so that either whether we're debugging or wherever we're looking at the console, or anywhere where our object can be represented as a string, the default is to display the name of the class, maybe the pointer in memory where our class lives, right? Our instance lives, and that usually is not very useful. So it's better for us, especially if you're going to look through a stack trace, or looking through and for debugging purposes, it's so much easier, right, to convert it into some string representation that actually makes sense to us, right? And we already have that anyway, right? We already have a function that can take this instance and convert it into some user-friendly, human readable format. So that's a pretty easy no-brainer, right? So there we go. So we're going to be using as hours, minutes, and seconds, right, to convert it into a human readable format, and that's what toString is going to return. Yes.
Since we're creating a toString, what's the purpose of having the separate method as HMS if its whole purpose seems to be just to call by toString?
Yeah. Well, no, it's not all. So as HMS is meant to be used in other contexts, right? Not only in toString. And also it's a domain name that makes it explicit, that is being used for that purpose in this domain of duration, that is hour, minutes, and seconds. Whereas toString is too generic, right? I don't really know what it is, right? Whereas HMS makes it explicit that this is the format that I'm going to give you back, right? So typically, interfaces are very useful for that, right? That you might have very generic functions downstream, right? But you either put a very thin facade in front of something that's very generic, and that facade gives a more meaningful semantic meaning of what is that is being used. So, for instance, very common, for instance, that you're hitting a database, and the function is dot find, and you put a select statement. Oftentimes, even though you're going to use that many times, typically you wrap it around a more high-level function that says find user by salary, right? And now it gives you a semantic meaning of what is that's happening. And it's much easier to code to a higher-level interface than some very cryptic, meaningless interface, right? Even though it might be doing the same thing. Yes.
When should we use this, like when we're calling methods? Because in previous classes we were basically encouraged to use this, like whenever we were.
Yeah, you should use this all the time. Yes, I'm lazy here. Yeah, it makes it explicit that you are within this instance. That makes sense. Yeah. Yeah. So even though you might have low-level interfaces that might even implement something that is trivial, it's a good idea to always wrap it around something that's meaningful. Yes.
So you'll be like, for example, we'll be calling toString and somewhere, right?
Well, toString is not called necessarily only by us. It's called by lots of folks.
Right. So okay, it's called somewhere by someone.
Yeah.
By something. So like, and why would we have to call toString instead of just calling us HMS?
Right. So again, toString is a defined on the object class, right? And so we're just inheriting it just because we're an object. So for instance, if I somewhere say system.out.println duration 1, right? It'll call toString, right? It's a part of the framework, the Java framework, that whenever an instance needs to be represented as a string, it'll call toString, right? We happen to already have an implementation of how we want to represent it.
So toString is like part of the Java framework.
Yeah, it's part of the Java framework. Yeah. So if you're iterating over durations, right, and you say some, and you print it to the console or whatever, right, it would return whatever you say to return here. Right? If you say hello, it'll return hello.
Okay, that makes sense.
Okay? Yep. Yeah, I was just pointing out that it's a good idea, right, to override the object.toString, right, that you inherit from the object. All objects have the toString function. Right, and then we have equals, and so which we also inherit from object, right? Object declares an implementation for us for every object instance that we all inherit. The default implementation is to do a shallow compare, right? I'm just going to compare the pointers. If the pointers are the same, obviously they're the same thing, right? But we might want to go a little further. Right? We want to say, well, no, I want to compare two objects, even if it's not the same object. Right? I want to do a deep compare. Right? I want to look at see if the actual values, if the states are the same. Right? If the hours are the same, if the minutes are the same, if the seconds are the same, then they're the same. Right? Don't just settle for a shallow compare. Do a deep compare. Right? Go in and iterate over all the state. See if they're the same. Right? So here we're going to override the equal, just like toString. We also inherit equals. We inherit it, and that's the signature. Right? It returns Boolean. It accepts a generic object. And so we're going to override. We're still going to stick to we're going to first check to see, this is basically what we would inherit. Right? This is basically what we would get for free. Right? We still want to do that. Right? We still want to make sure that, hey, if it's the same instance, right, if it's the same address, then obviously we are the same. There's no point in checking the states, right, if it's pointing to the same memory space. Also we want to make sure that if you're passing me something other than a duration, right, then it makes no sense in comparing. What am I going to waste time comparing if you pass me something that is an object, but it's not the right object, right? Because I could inadvertently pass something else other than duration. Yes? Yes?
Wouldn't you want to be more general there and check if it's an instance of duration?
We'll talk about that in a minute. Yep, that's where we're going. Yeah, well, so somebody caught here that we are comparing against a particular implementation. All right, we'll come back and fix that in a minute. Very good, very good. So we're checking to see, because notice that we're implementing this where? We're implementing it inside of the duration impl. So our first impetus would be to check to see if, again, comparing if it's another instance of duration impl, right? And someone caught that it would be better, right? It would be better that this were not duration impl, but instead it would be duration, right? It would be better. We'll see that in a minute. So this is what we're doing here is that we are strongly coupling the implementation to a specific implementation, right? And one of the principles that we want to apply is that we want to decouple, right? And we don't want to be tied to any one particular implementation. So we'll come back to it in a minute and we'll fix it. So the point here that I was trying to make is that if we're not the same type, why even bother comparing it? I'm just going to return false. Okay. And then lastly, the deep compare. The deep compare would be, okay, so if I'm not the same instance, but we are of the same type, right? We're going to do the deep compare. Right? I'm going to check to see the two states. If they're the same, then yes, they're the same. Yes.
Didn't we say way back at the beginning that we wanted two equivalent lengths of time to be the same, even if they're represented in different minutes, seconds?
Yeah. We'll go there in a minute. Yeah. There's another capture here that we are, again, here we are tightly coupling to this particular implementation. Very good. Yeah. Yeah, and again, so we're breaking one of our principles, right, of decoupling, right, of not depending on any one particular implementation. So that's equals. hashCode is also, typically when we implement equals using a particular implementation, we usually also along the same lines we also implement hashCode. Typically using the same strategy or the same idea that we implemented equals. So here we're overriding hashCode, and we're gonna use the low-level implementation of hash that takes any number of values here, and then it hashes them individually, and then takes them together, and then creates a new hash, based on the hashes of each one of the values, and that's what we return. So typically we implement both, right? Equals and hashCode along together, right? We either override both or we don't override either. So that's a hashCode based on the same assumption that we're using hours, minutes, and seconds to compare. Yes. I'm sorry. Right. So hashCode tries to come up with something that is unique. A representation that represented as an integer that can then be used as an index, right, into some collection, right, either a hash map or a hash table, and then I can order it in such a way, right, that the same values hash to the same index, right, so that I can then very easily look it up into an indexable collection. Right, so it does a conversion, does a map of an infinite set of values into a finite set of integers in this case. Yes? Yes?
Wouldn't this make different kind of formatted versions of this not equal? Like a minute and 30 seconds would be different than 90 seconds if we use this one.
Right, yeah, in equals, we took care of that, right? Equals does a comparison, right? hashCode would be different, yes, and that's fine, right? But we're going to fix that in a minute, so that we use the canonical version instead of this version, right? As some folks were pointing out, right? A better equals. So a better equals is one that is not dependent on any particular implementation, right? We had inadvertently used because we are inside of the duration impl. Our first impetus is to use all references to that particular implementation. But a better solution would be to not be tied to any one particular implementation, right? Because we have already functions that, whatever implementation you're running in, whether it's this one in particular, right? You will be overriding functions that were declared in your parent interface. Yes, right. So you can always be casted back into that particular interface, right? So here we're going to check to see. Still, we're going to check to see if it's the same pointers. Then why even bother? Obviously they're the same. But here, instead of using the particular implementation, right, we're going to say, oh, is it an instance of duration? Obviously, if you're an instance of some child, you're also an instance of some parent. Yes? So if you're duration impl, then this is true, right? Or if you're not, right? If you're not inheriting from, or if you're not implementing that interface, then this would be false. Right? So why even bother, right? To check to see if you're not even inheriting from this particular implementation. You're not implementing this interface, right? So yeah, why bother? So yeah, so this decouples us from any particular implementation, right? And so this can be useful for any implementation that comes forward, right? That we might have later on. And down here also, like somebody was suggesting, right? We're casting it back to duration, and we're just calling it in seconds. And every implementation will have implemented this method, right? Converting from any particular implementation they might have internally, whether it's hours, minutes, and seconds, or moons and sols, or whatever. Right? It'll convert it back to integers so that we can then compare it against the same implementation of this in seconds and say whether it's true or false. Right? Again, we're no longer tied to any specific implementation that goes through here. Yes? Yes?
In your signature, do we always overwrite the equals that takes in an object rather than like have one that takes in another duration?
Yeah. Yes. Right. This would be object. Right. Otherwise, it would not be an override. Right. The signature of the equals takes an object. Then it would not be an override. It would be an overload. Yeah. So if it's something other than duration, it would call this one. But if it's a duration, then it will call your new one. Yeah. Oh, to me, no. It's always a good idea to use the equals, the one that it's inherited from the object, and then rewrite, or maybe even do super. Call the super implementation and see. Well, do whatever you do normally, and then come back here and continue doing some more comparisons. Yeah, no, it's a good idea to do the base implementation, to override the base implementation. Yep. Since we changed the implementation of equals, the same challenges, the same problems we would have run into hashCode, right? And so instead of using the implementation of that particular implementation, right? We're converting it back into the canonical form, and then we can just run the low-level hashCode for long in particular. Yes.
Sorry, on like the last slide, you do like different if statements that you do return true, return false.
Yeah.
Is there like a specific reason you don't just return one single return statement with or statements?
Here?
Yeah.
What?
Like return duration or this equals that or that.
Yeah, it's stylistic. Yeah, yeah. Also, obviously, you would not code it in one single line, right? You would have all the white spaces, and only so it could fit on the slide. Yeah, hashCode. Yeah, and finally, document this going back to the interface. Any of the assumptions that you might have made as you were implementing the interface and that particular implementation. Go back and add perhaps some light HTML. Since this is going to be processed by JavaDoc, right? It's going to convert all this to an HTML. Yes.
If we do not know HTML.
Don't use HTML. But you have here some samples, right? Some really light samples on creating line items and unordered lists and paragraphs. Right? Yeah. What JavaDoc does is that it parses all these comments, right? And it creates a website, an entire website. It'll create for every class or interface. It will create a page, a separate page, and then you can navigate as a documentation and say, okay, well these are all my classes, all my interface. I click on it, and then I have a whole page that documents my class, right? So you run JavaDoc. So as part of your bin directory, you'll have Java, Javac. One of them is JavaDoc, and so you run JavaDoc at the root of your class, where your classes are. It parses all your classes, right? And it generates a folder, and under that folder, you'll be an index page plus, tons and tons of HTML pages in the same package structure as the package structure that you wrote in your classes. So it'll create an equivalent package structure with, instead of classes, it will have it will have HTML pages in there. Right? So this is to foster the practice that as you're developing, as you're coding, right, you are documenting this, right, and documented it in a standard format, right, so that you're not maintaining two different pieces of artifacts. The source code is the documentation, right? It doesn't live anywhere else. As you're coding, you're documenting as well. All right. All right. Okay. All right. So that's all I have for you.